Hi, so today we have a MacBook Pro 15-inch 2010 on the desk. So this MacBook Pro is turning on, but we have a problem with it. So you are gonna see that right now. So as you can see, we have an image. It seems to be working, but if we look closely, we have some artifacts over there and the vertical line over there. So if we log in, it's a bit hard to see, but there are some green artifacts over there, and it's easier to see right there on the icons where it's supposed to be white. You have some pink lines. So when you look at it like this, you're gonna open an application like Activity Monitor with a white background, and you can see there are a lot of vertical pink lines. And you may think, well, it's just a dead GPU on this machine, but in fact the GPU on this model very rarely dies. What's more likely to happen is to have the capacitor C9560 that's going bad, but here it's not the problem either. So just to confirm, it's not a dedicated GPU related problem. We are gonna use JFX card status, as you can see here. So this application can switch between the integrated GPU, so the Intel GPU, and the discrete GPU, which is the NVIDIA GPU on this board. So here we just switch to the NVIDIA GPU, and as you can see, it is doing the exact same thing. So let's switch back to the Intel GPU. So it switched back to the Intel GPU and the same problem. So it's not especially related to the dedicated GPU or the integrated GPU, but there is still an issue on the image circuit. And what's interesting as well is that if we start to poke at the board, you can see that the issue goes away. So if we press at random places on the board, it changes the issue. And in fact, if we press somewhere in this area, you can see that the pink lines go away. If we touch the display connector, it's not doing anything, so it's not related to the LCD connector or the LCD cable. We know that the LCD is working. We already know that it's the board itself that's the problem. So it's something on the board. And right in this area, in fact, this chip right here is the GMUX, the graphic mux. It's combining the signals coming from the dedicated GPU and the integrated GPU to switch between them and output the image on the screen. And if we press down on it, you can see that the issue goes away. So just to take a quick look at the schematic. So we have an 820-2850 board in this machine, and as you can see on the screen right there, we have right here the dedicated GPU, NVIDIA GT 216. Okay, so this is the GPU we have on this machine. We have over there the CPU, and the big block on the center is the PCH. So the PCH has multiple display outputs, and we have right there the LVDS output from the PCH. So it takes the image generated by the Intel GPU inside the CPU and sends it to the screen. And same thing with the dedicated GPU. There is an LVDS output that sends it to the screen. And between these two, we have right there the graphic mux. So So this is the chip you are interested in. So if we take a look at the board view of this board, so we have the board view right there, and the area we were looking at was this area. And right there, the chip I was pressing on just earlier is here, U9600, which is the GMUX. We know the issue is most likely with the GMAX. So what could have happened here is that maybe the machine was dropped and now we have bad contact under the GMAX. So we are going to reball it, hoping that the pads are fine and just bad contact with the solder balls under it. So just to show you again, the chip is right there. Right now we have those pink lines on the screen, and if I press down on the chip, you can see that the pink lines go away. So let's turn off the machine, take out the GMUX, reball it and put it back on. And on a black screen you can see those green artifacts, which are also related to an LVDS signal issue. In general, in fact, the green artifacts and the black image is a typical symptom of an issue with an LVDS line. So we are gonna put just a bit of flux because it will help removing the edge bonding and getting the chip out. Okay. Get some tweezers, turn on the hot station. So for now, just to remove the edge bonding, we're gonna set our hot station to 200 degrees Celsius. We're not gonna melt the solder yet. So let's go. Right now we are gonna take off the chip. So just to make our life easier, we're gonna add a bit of flux. Okay. Increase the temperature on the hot station. So here we have our GMUX pads under the microscope. So you can see the leftover of the edge bonding that we are gonna have to clean up as well. For now, what we are gonna do is apply some leaded solder. And tap some flux. We are gonna tweak those pads. Let's clean up a little bit. Okay, so now that we are clean on the board, we are gonna have to reball the GMUX. So let's put the machine aside and get down to it. So first we are gonna flow some lead solder onto the balls. Make sure they get nice and shiny. Okay, should be good enough. Now we are gonna remove the solder with some solder wick. This solder wick is complete garbage. That's what you get when you buy the cheap stuff from AliExpress. Yeah, this is gonna be good enough. Let's put some flux. I like using the Cheap Quick SMD 291 for reballing because it's more tacky. The stencil stays in place better. I think it's too cold for this flux to work properly. Let's heat up a little bit. So we're gonna add some flux on the pads. Let's place the chip. So it goes on in this orientation. So it can be quite difficult to align properly. So what we are gonna do is take a look under another board which happen to have the same problem, and we are gonna check where it's supposed to align. So if we check on this corner, you can see that this corner aligns with almost the end of this cap. It aligns with this end of this resistor. On the top, this corner aligns with this cap, and it aligns with this end of the resistor. Here it aligns with this resistor, the 2, and it aligns just below this resistor, and this one aligns with this cap over there and a bit to the left of this resistor. So we're gonna try to replicate this alignment with our chip over here. So the chip goes a little bit to the bottom here. So we align here, it goes to the right. To align with this resistor on top. Okay. Here it aligns with this cap, okay, it aligns with this resistor. Over there we're a little bit to the left of the resistor and we are aligned over there. On the top we are on the second resistor and a bit below the top one. So it should be good, so let's try to reflow the chip. Okay, so the balls flowed, just to make sure we nudge it a little bit. We're gonna clean up a little bit. Okay, so we did replace our GMUX, so it's soldered back over here. While I was at it, I did solder back the speaker connector right there that was missing. It's not on camera, but whatever. So now we plug in our screen. We're gonna plug in the speaker to get the chime. Okay, let's plug the front LED. So let's connect the keyboard. Okay, and touchpad as well, of course. Here is the hard drive. Okay, Let's plug in the other stuff as well. So that we make sure everything works as it should. Okay. Keyboard backlight. Good. Battery indicator LED. And then battery. Okay, so we are booted into macOS, and for now we don't see any issue on the LCD. So let me enter my password. Okay, so we are fully booted into macOS. So this is High Sierra, and for now we can't see any artifact on the screen. So what we are gonna do, I already selected discrete GPU, so right now we are running on the NVIDIA GPU. We're gonna switch to integrated only, and now we are on the integrated Intel GPU, and there is no artifact at all on the screen. If we tap the board, nothing changes, and if we press down on the GMUX, everything is fine. So in this particular instance, it was indeed an issue with the soldering of the GMAX. So we reballed it. In fact, I used another chip, but it doesn't matter. So we reballed it, and it fixed the problem. As you could see, there was no damaged pads, so it was just the solder boards. It probably failed as a result of a warp of the machine. Of course, this applies in this specific case for the GMUX, but when we have a failing GPU, for example, it's very rarely the solder boards. Most of the times, it's the GPU chip itself that's bad, so it has to be replaced. And if ever there was an issue with the soldering on the board, very often when you take off the GPU, the pads under it are damaged as well. So this was the fix on this mid-2010 15-inch MacBook Pro board, model number 820-2850. Of course, this board is also affected by the well-known dying capacitor C9560. So we are gonna replace it off camera. I already did a video on this. We are gonna replace the tantalum capacitor by an aluminum capacitor.